Good afternoon. I'm Michael McTeer. I'm an emeritus professor at Ulster University in Northern Ireland. I've been working with conversational systems for more than 20 years, and today I want to talk about some issues that developers and designers face when creating conversational interfaces, and also some of the solutions that have been proposed. We can see conversational interfaces everywhere. Sometimes they are text-based, also known as chatbots. In other cases, they are voice-based, also known as smart speakers. Then we have those that have screens for display. We have conversational systems on our smartphones, wearables like smartwatches, and various smart devices in the home and also in the car. But what actually is a conversational interface? Well, the basic idea is that with a conversational interface, you can talk to an application in a conversational style. And quite simply, this means that you take turns at talking, just as in a natural conversation. And this may be to accomplish a task, or it may be to simply engage in a conversation. From the user's point of view, this is potentially an easier way to interact with computers. You simply just ask a query as opposed to navigating menus and drop-down boxes. Conversational interaction is a major focus in much of the current work in AI. Conversational interaction is seen as one of the hallmarks of human intelligence, and as the authors of the Google chatbot Mina have written, it's likely to be seen as a requirement for true artificial intelligence. However, it's not all good news. For some people, conversational interfaces are actually the worst thing that has happened to usability since MS-DOS, particularly when they don't work very well. In a report by the Nielsen Norman Group, it was said that these systems only work for very limited simple queries with fairly simple and short answers. In other words, they're not really very usable at the moment for more extended and more elaborate conversations. Now, if we look at how conversational interfaces can be developed, there are basically two approaches. The traditional approach is to design the interface, to handcraft the various aspects of the interface, the conversation flow, and the various modules using best practice guidelines. And there's a long tradition of this. Formerly, these were called voice user interfaces, and there's quite a considerable literature on how to develop them. As opposed to this, there is what has come to be known as conversational AI, where technologies and methods developed in artificial intelligence research are being used now to create conversational interfaces. In the old days, symbolic approaches were used to implement AI, approaches using logic and plan recognition and rational agency. But in more recent times, data-driven approaches have become prominent, where either systems are developed based on corpuses, large amounts of data of previous dialogues. Another technique is the use of reinforcement learning, and most recently the application of deep learning, deep neural networks, for the development particularly of open domain conversational systems. Looking first then at handcrafting a conversational interface and at the aspect of designing the conversation flow, the recommended steps are to first of all write some sample dialogues, and then from those to diagram high-level flows as shown in the example here on the right hand side, and then to test and iterate over these designs. Having designed the happy path where things go as expected, to then look at unhappy, or what are sometimes called edge cases, cases where errors occur, and to implement these as well. And then finally, having designed this, to implement the design using some particular framework. Now, this doesn't always go to plan. So I have a couple of examples of where design has gone wrong. In this particular one, it's to do with getting quotes for stocks, and the system has elicited Apple as a company, and it gives an answer for the stock, and then asks the user if they want to hear another one, to which the user then quite reasonably says, Microsoft, please. The system doesn't understand this. The user repeats, possibly a little bit louder, and then the system says, I'm sorry, I didn't catch that. Would you like to hear another quote? Please say yes or no. So in other words, when the system asks, would you like to hear another one? It wants to hear the answer yes or no, as you can see here in the flow for the diagram. And only when it's got yes or no will it then continue with either asking for a quote or closing down the conversation. Another example, which actually is the opposite to that one, is asking the user to provide a day and hour for when they might want to go shopping, and then telling them if that's a good choice. And so here we're told that that's a quieter time to shop, that's fine. And then we're asked, are there any other hours we can check? So you might think you could say yes or no. In this case, we've said no. And the system says, sorry, I didn't get that. Could you please repeat when you want to go shopping? Please provide the day and hour. So as you can see, in both cases, it doesn't go to the designer's plan. And when the user interacts in a fairly natural way, things go wrong, and it's not actually very easy to recover from that. So regarding handcrafted approaches, these are used very widely in commercial systems, in current commercial systems, and so there is a large body of best practice guidelines. And one of the advantages is that the designer has control over the whole process. They can anticipate and locate problems, although as we've seen, not necessarily in every case. But then the disadvantages, well, because it has to be handcrafted, what we find is that sometimes it's not all that easy to adapt it to a new domain. You have to redesign a complete system. It can be costly to develop. It's very expensive in terms of conversational designers and developers, requiring advanced skills in order to engineer the system. In many cases, it's not completely robust, and as we found, it can be difficult to recover from misunderstandings or unexpected input. So one other approach that particularly is used in developing a conversational flow is to use data. That's to enable the system to actually learn what has been called in this approach a dialogue policy from data. The data is actually the feedback that the system receives, which is why it's called reinforcement learning, indicating whether the interaction has been successful or not. In order to do this, the dialogue is modeled as a sequence of states, and as the system moves to a new state, it will select an action from a number of alternative actions, where several of these are available in that particular state. It receives a small reward and then moves on to the next state. Eventually it comes to the end of the interaction, and the goal is to find a sequence of states where the actions have been chosen that will minimize the long-term cost of the dialogue and maximize the final reward. Now that all sounds rather abstract. A simple example would be, for example, deciding whether or how to confirm a user's input, or indeed whether not to bother and to move on. Now, in a particular situation, that action may appear to be suboptimal in the short term because it then makes for a longer dialogue when you're trying to minimize the length of the dialogue. But on the other hand, it might in the long term be more successful because it leads to a successful completion as opposed to one in which there is a breakdown in the communication. The problem, however, is that optimizing a policy using reinforcement learning can quickly become intractable. Now, within this approach, and indeed with other approaches in advanced approaches to dialogue, there is what is called belief state tracking, or sometimes also dialogue state tracking. What this is doing is representing the system's belief about what the user actually wants, and also about the state of the dialogue so far, how things have been going. Now, because a lot of this information is uncertain, so for example, when the speech recognition returns a result, this may in fact be uncertain. As we can see in the chart on the right hand side, there are various degrees of belief state. To the question, are there any bars that play jazz? And so in this approach, the belief state is represented as a distribution over all possible states, so that the system will pursue all possible dialogues in parallel. This has the advantage that it doesn't have to backtrack if some error has occurred, but the problem is that there's not enough data in order to train systems in many cases, and this only seems to work for fairly small systems using very simple form filling, and when you try to scale it up, it becomes intractable. Recently, deep learning has been applied to the development of conversational systems. In the diagram, we can see an encoder-decoder architecture in which an input sequence is mapped onto an output sequence, known as sequence-to-sequence mapping. During the process of the encoding, the input is encoded, resulting in a thought vector which represents the input, and then this is taken as a basis for the decoder, which generates the output on a token by token basis. This particular architecture can be applied to the modules of the conversational system. So for example, for the speech recognition module, it can be applied to represent the sequence of sounds as the input, which are encoded, and then these are decoded as words. Or in the natural language understanding, a sequence of words is input to the encoder, and the output is the meanings of those words. There's a very interesting description of these processes in the recent book by Steve Young. This idea has been taken further in sequence-to-sequence mapping for conversation, where the input to be encoded is a complete utterance, and then that is represented as a thought vector as before, and a decoder will then provide an output as a response to the input utterance. In other words, conversation is treated as a source to target sequence transduction problem. This has been used very successfully in different types of application. So for example, in automated email replies and also in translation. But to date, there are still lots of problems that occur in trying to apply this approach to natural conversation. One of the advantages, however, is that it does not require the pipelined architecture that has traditionally been used for conversational systems, where you have separate modules and information has to pass between them through a pipeline. One of the difficulties there is that when you try to optimize one module, that can have a knock-on effect to the other modules of the system. And so if you don't actually have the modules at all, then you can actually do away with that particular problem. However, there are some issues with this approach. First of all, it requires large amounts of training data, but for many domains there isn't very much suitable training data. It's difficult to represent context. In some cases, the context only goes back to the beginning of the incoming utterance. In a very large system like the Google Mina chatbot, the previous 7 utterances can actually be used as the context of the immediate history. A different approach is a different issue is that there's a lack of explicit long-term memory, which can lead to semantic inconsistency, where the system, for example, will tell you that it's 25 years old, and then later will say that it's 45 years old, and there's really no consistency in the output from the chatbot. And another problem is that quite often it will produce bland and uninformative utterances, which in the training data actually have a higher probability. That's utterances such as "that's great" or "I don't know," which don't actually take the conversation further. A recent book by Gary Marcus and Ernest Davis has looked at deep learning in relation to issues such as language understanding, and a point that they make is that deep learning does not make use of compositionality to understand input. Compositionality refers to how the parts of a sentence contribute to its meaning. So it's not really sufficient just to take the keywords in the input, such as in this example, fast food restaurant, and near me, and KFC. A crucial role is played by the word "not," which constrains the restaurants that ought to be returned. And in a trial with this example to a well-known smart speaker, the answer returned 3 KFC restaurants, which was obviously not the intent of the input query. More generally, understanding in conversation requires the ability to create a cognitive model of the conversation, which will include being able to represent and connect to what was said before, keep track of the intentions and beliefs of the participants, and various other things, and then also to be able to reason over these representations. This brings us to the idea of a hybrid approach. Current research focuses on deep learning and deep reinforcement learning, but there's a need for the ability to look at earlier work. So as Darwich has said in a recent paper, we need a new generation of AI researchers who are well versed and appreciate classical AI, machine learning and computer science more broadly, while also being informed about AI history. Finally, I would like to look at the idea of conversation system design as a UX, a user experience driven approach. Currently, most work has focused on issues of design and implementation from the point of view of the technologies being used, but it's also important to consider user requirements and to engage in a process of co-creation with the users, so that the systems that are developed are systems that users will want and will actually use. And having then designed and developed these systems, we need to look and see how the systems are in fact used. For example, if the interactions with the systems are successful, and what happens when they're not, what users do when they're not successful, and what users think about the interactions, and so on. This has been referred to by the developers of the RASA platform as conversation-driven development, or CDD, and it's the focus of quite a lot of recent conferences. For example, the CUI Conversation conversational user interfaces conferences, the conversations workshops, and also the Chatbot Europe conferences. So to wrap up, there's a need for an approach that combines the strengths of deep learning and big data with insights from classical symbolic AI. And as regards conversation design, there's still a need for design experts, also known as conversation designers, and for the design to be user-driven in a process of co-creation. So with that, I'd like to thank you for listening, and I welcome any questions that you might want to ask. Thank you.